And by this means we can understand that there should be a sphere on the drawing. It's written R for the radius, and wherever the radius comes, for example chamfer or fillet or some curvy part, the radius is shown from the center and is written R, and what is the length of the radius. The next is control radius CR, spherical radius SR, and so on. We have this type of special symbols mostly used. For example, there is a taper shown on the drawing that the size is slant, and the drawing is a slant is shown as a taper symbol as shown. And conical taper means taper from both sides is shown as a conical taper, like a triangle and the line passing through the middle. So the dimension rules, it is very important to understand and follow these guidelines, because dimension rules are basically designed to carry out the dimension. There will be no error, and the drawing will be should be interpreted by minimum effort. So the first rule is it should be perfect. Dimension should be calculated and measured, and finalized dimension only should be written on the drawing, so that the interpreter or the production person should not calculate, assume or measure the dimensions. Second one, dimension must give outside of the geometry. If the geometry is bigger, even though we should try to give the dimension outside the geometry, so that there will be a minimum chance of clash between the geometry. Third one is place the view relevant to the features. So we should place the dimension in relevant views. We will see in orthographic view that there are more than one views, and certain features can be visible in certain views. So one should give the dimension in visible view only, not the hidden one. So the next one is no repetition of the dimension. Hence, there are chances that there will be same features in the both views, so the repetition should be avoided. Repetition of the dimension always can mislead the interpreter, because the interpreter tend to think that there will be a separate feature or something design will be changed in that view. So repetition of the dimension must be avoided. On the next one, we have given the visible line. The dimension is always given in the visible view and never on the hidden view. We cannot see the hidden things. Hence, the dimension and the extension line should not be given on the extension line, and it's always given on the visible line. Next one is it should not cross to each other. Well, the crossing of the dimension is very poor practice. If the dimensions, if given inside the geometry, there are many chances that extension line will cross the dimension line, and hence there will be a confusion in reading and it will be a poor practice. So the crossing of the line of dimension is prohibited and it should not be practiced. So the next one, the number 7, is there should be maintain a gap of 5 to 6 mm between two dimension and two visible lines, or from the dimension line to the edges and the dimensions. It means the dimensions can be visible and there should be some gap, and one should maintain this space in order to read very clearly these dimensions, and within this dimension and the edge and the dimension line. So by this space the dimensions can be read, even though there are many dimensions in the features in the objects, and there are chances that these dimensions may overlap each other. Next, two dimension rules. The center line of the object should not be used as a dimension, extension line or projection line. So there are 10 to chances that there are many circular parts in the object. So there are many center lines. Center lines are drawn by showing the 4 quarters of the circles, and center line should be extended by the diameters of the line, and hence this center line of the object never be used as a dimension. One can use the extension line of the center line but not the center line as a dimension line. Next is place the dimension of various views to avoid crowding. Stagger the horizontal dimension in order to avoid the context or crowding of the values. So the values also be staggered rather than writing on one above. And on the next one, conserve the space and time by using abbreviation. We have seen some symbols before that instead of writing radius, one should write R, or instead of writing diameter, one can use the symbol 5, or instead of writing spherical radius, we can use the symbol SR. By this way, we can save the space as well as time. The space is very important in the drawing, and one should use the dimension very clear and use the space wisely. On the next, these dimensions we should follow this dimension very clearly. And next is dimension guidelines. We have many features like holes, contours, radius, fillet, chamfer. These features, this term is called features. As we can see, it refers to surface faces, holes, slots, corners, bands, arc, fillets that adds up to a form of engineering part, and we must give the dimension to these features. Dimension define again the size and the location relative to each other features, or a frame of reference is called datum. We have some example of important element of dimensioning. We have cross section of some part. This cross section is called hatching line, and is showing by lines crossly the continuous thin line, and the radius, as we can see, it is written R, and it's showing by the center to the radius. If it is outer radius, the center must shown by the two crossing lines perpendicular to each other, and it's written R75. So the arc dimensions are shown by this way, by showing their radius. All the ladder lines passes through the arc center. So this way we can use the ladder to show the arc. Dimension an arc by its radius. Locate the center of the radius or two tangents to the arc. So we need to show the center as well. Dimension for an angled faces. There are certain chances where we see the taper or the slant section, so we need to give the taper angular dimension that show the slope or slant surface, like this way. As shown on the screen, dimension of an angled face is showing one corner of the angled surface is dimensioned, and the second corner of the angled face is located by intersection. As we can see, the slant, the angle is shown by the figure and a small round circle by angle. The arc used for the dimension line when immencing of an angle is centered on the vertex of the angle. Chamfer are generally 45. So what is chamfer? Usually the production people, when they are making some component from the steel, when the plates are cut, there are sharp edges on the plate. So these plates are to be chamfered so that the edges are not sharp, just to cut the sharpness of the plates. So this is called chamfer. For chamfering, we need to cut the sharpness 40 by 45 degree. Repetitive features. So the use of repetitive features in engineering application, there are many examples where we can find where we can encounter more than one features repeating. So it is advisable that not all the dimensions are given, but the one dimension is given and it's shows the cross symbol like this way and multiply the number of features. Here we have hole of diameter 0.375 inch multiplied by 4 times, so it's on the every 90 degree we have 4. So by this interpretation we can understand that there are same hole number of 4 times of 0.375 inches. So we are using this symbol to give the dimensions of the repetitive features. And we also, for example, in this figure we have 2 holes. So here it's written 2 times 6 diameter, and this edge is reference datum surface. This is defined as a datum surface. So these dimensions are showing as a parallel dimensions, and here we have this dimension as a chain dimension. So we have seen all the types of dimensions here, and it's given from the edge to edge. So we have seen the dimension is a numerical value expressed in appropriate units of measure and is used to define the size, location, orientation and form or other geometric characteristics of a part. So to summarize what we have seen today, again the term engineering drawings is called a graphic language, and the importance of engineering drawing. Again, it can be used by many engineers and it should be interpreted by many engineers. For example, a planning of a layout drawing of a plant, for example, can be produced by a civil engineer and can be interpreted by project engineer, process engineer, equipment engineer, piping engineer, firefighting engineer, mechanical engineer for rotary part or stationary part, and hence there are many engineers, those who are going to read the same drawing produced by one country. So one drawing can be used more than in one country, and this drawing should be interpreted without any hassle and without any problems. So this drawing should be clear and without any inadequate data that are difficult to understand. Hence it's called a universal language. One should remember the standard. We are using BIS IS 696 1972 standard, that is the code of practice and for drawings. We have seen today the use of standards, how the standards applies to layout and sheet orientation. The layout and sheet orientation as per this IA standard JIS is given as A4 to A0. A4 means our regular size paper that we use to print the stationery at our home, and A0 is the largest size, which is 841 multiplied by 1189 mm, which is the largest size. Orientation of the drawing can be seen by this way. The horizontal is drawing space and the margin is kept. Why margin is kept is to bind the sheet or to keep the record. So the drawings are to be folded in a way that the title block and the information should remain above and visible, so that it is easy to segregate the drawings and to record the drawings. All the drawings can be stored by filing. Nowadays it can be recorded in a computer as well and kept the printed record in a filing. So to filing and binding, the margin on the left side is kept the bigger, and this is the purpose for the margin. And next we have seen the scale, why scales are used and why there is a need of scale, because we have limited space for the drawing, and the drawing object can be of any sizes, so we need to use the scale wisely. We have seen line types and what the difference between the lines and the applications and why it is important